Okay, so let's unpack this. The goal is just, well, monumental, sending humans all the way to Mars.
Right, absolutely. And the vehicle, the tool for that job, that's SpaceX's Starship.
Exactly. And the info you've gathered for us today, it drops us right into a really critical moment for that whole program.
Yeah, it really does. Because today, May 27th, 2025, SpaceX is actually gearing up for its 9th flight test of Starship.
Live from Starbase down near Brownsville, Texas. Launch window opening, 7:30 p.m. Eastern time, I believe.
That's the plan.
Yeah.
And you really get the sense, like you said, the stakes feel pretty high this time around.
Oh, yeah, especially given the last 2 test flights. The upper stage didn't quite sticks the landing, so to speak. Both were lost.
Exactly. So after those outcomes, there's definitely, a lot of eyes on this attempt. People want to see what they've learned, what's different.
Right. So our mission here for this deep dive is to use these sources we have and really get to the core of what's going on. We need to understand, what really happened on those previous flights, what are the key takeaways, and then dig into what SpaceX has specifically changed or what they're testing on this 9th try.
And maybe figure out why this really fast pace of testing, even with, sometimes explosive setbacks, is just so vital to their big vision.
Yeah, that Mars vision.
It really all comes down to proving this massive, massive system can fly, do its job, and come back safely and reliably. That's the hurdle for putting people on board eventually.
Okay, so let's rewind a bit. Those recent challenges. Flight number 8, back in early March. What did the analysis say went wrong there?
The main thing points to a specific hardware failure. Happened about 5.5 minutes after launch.
Okay.
Apparently it caused fuel to mix incorrectly, basically. Led to a bad ignition, loss of control, loss of communication, and yeah, the vehicle likely triggered its self-destruct system.
And the aftermath was pretty visible, wasn't it? I mean, debris reportedly came down over South Florida, parts of the Atlantic.
Yeah, even caused temporary ground stops at some airports nearby. Really underscores just the sheer scale and energy involved here.
Right.
And that wasn't the only recent upper stage loss, remember. There was a similar end result back in January, though the reason was different.
Oh, right, the January one. Wasn't that linked to vibrations?
Yeah.
Stronger than they expected.
Exactly. Those vibrations apparently caused a propellant leak, which then led to an explosion.
Huh.
So what's kind of interesting is, both times the upper stage was lost around that same point in the flight, that 5.5 minute mark.
Yeah.
But the actual technical reasons were totally unrelated. Different problems cropping up at a similar stress point in the mission profile.
So different causes, same result for the upper stage.
Right. And SpaceX has been pretty clear they've taken lessons from both incidents and fed those into the changes for this flight today.
Okay. But amidst all that trouble with the upper stage, the first stage, the super heavy booster, that actually worked out okay in those flights, didn't it?
Oh, absolutely. And this is super important for their whole reusability plan.
Right.
In both the 8th test and the January one, the super heavy booster flew back perfectly, returned to the launch site, and was caught by those giant robotic arms on the tower. The chopsticks.
The chopsticks, yeah. That's a huge piece of the puzzle, proving that part works.
Definitely a major step forward for their recovery architecture.
Then maybe just worth stating really clearly for anyone listening, none of these flights, not the previous ones, not this upcoming one, had or will have any astronauts on board. Purely uncrewed tests.
Correct. All developmental flights. So now, looking at Flight 9 today, there's quite a bit that's new, quite a bit that's different, directly reflecting those lessons and pushing things further.
Yeah, you get a sense of the sheer scale when you think about it. The Starship sits on top of that massive, super heavy rocket. What is it, 400 feet tall?
Something like that, yeah.
Yeah.
Just enormous. Powered by 33 of their Raptor engines. It's, like the sources say, the most powerful rocket system ever built. And the dream, the ultimate goal, is for the whole thing, booster and ship, to be fully rapidly reusable. Launch, land, check it out, fly again. Way beyond even the Falcon 9, which is only partially reusable.
And this Flight 9, it's a pretty big step towards that rapid reuse idea, isn't it? Because this is the first time they're flying a booster that's already flown.
That's the big headline for the booster side, yeah. This isn't fresh off the factory floor. It's the booster from the 7th test flight, the one that flew and got caught successfully back then.
So what's the thinking there? Just fly it again as is?
Well, not quite as is. They inspected it, obviously. Replace things known to be single-use, like parts of the heat shielding. But the core idea was to leave much of it intact.
Okay.
They want to study how a real flight-proven booster holds up to the stresses of another launch and flight. Real-world wear and tear data. 29 of the engines are reused too, by the way.
29 out of 33. Wow. Okay, so they're really testing the hardware reuse. But wait, you said it flew back and got caught last time? Is it doing that again?
No. Different plan for this specific test. So instead of aiming for the catch at Starbase,
Right.
this reused booster is going to follow a different trajectory. It's aiming for a hard splashdown out in the Gulf of Mexico.
A hard splashdown, so not recovering it this time.
Correct. The goal here is to test some new flight profiles and different landing configurations, but do it over water first. A bit less risk than trying a catch right away with the changes.
Gotcha. And there's another specific test plan during that booster landing sequence too, something about the engines.
Yes. This is pretty interesting. They're planning to deliberately shut down one of the engines during the final landing burn.
On purpose.
On purpose. It's a critical test. They want to see if the control system can compensate and still manage a controlled landing, or in this case, a controlled splashdown maneuver, even with an engine out at that crucial moment. Basically, testing a failure mode.
Okay, so they're really pushing the booster. What about the Starship itself, the upper stage? That's where the problems have been recently.
Right. So the upper stage has its own ambitious checklist for this flight, trying to hit milestones they missed before.
Like what?
Two big ones mentioned are, first, deploying 8 Starlink satellite simulators. That'd be a first for Starship actually deploying a payload, even if they're just stand-ins.
Okay, deploying something. And the other?
Performing an in-space relight of one of his Raptor engines. Also crucial for future missions where it needs to change orbit or head off to the moon or Mars.
Makes sense. Now, about re-entry, you mentioned heat shielding. They're doing something kind of weird sounding, removing tiles.
It does sound counterintuitive, doesn't it?
Yeah.
But yeah, they're calling it intentional extreme heat testing.
Okay.
It involves literally removing some of the thermal protection tiles before flight. So certain areas of the ship will be deliberately exposed to more intense re-entry heat than they're designed for.
Why on earth would they do that?
To push the limits. They want to see how the structure underneath holds up, understand the exact failure points, gather data on the margins. They're also apparently testing some different tile types and materials in other spots. It's all about understanding robustness under extreme conditions.
Wow. Okay. That deliberate pushing, the flying again quickly, even after, things explode.
Yeah.
It really points to a specific way of thinking, doesn't it? There was that SpaceX quote in the materials.
Yeah, that quote really sums it up well. Let me see. Here. Developmental testing, by definition, is unpredictable, but by putting hardware in a flight environment as frequently as possible, we're able to quickly learn and execute design changes as we seek to bring Starship online as a fully and rapidly reusable vehicle.
That really is the key, I think. It reframes those previous flights. Less like outright failures and more like, incredibly expensive, very dramatic learning opportunities.
Exactly. It's about the speed of learning. For them, the fastest way to learn about flying to space is, to fly to space. As often as possible.
Get that real-world data, see what breaks, understand why, fix it, and try again. Fast.
Precisely. It's not about getting it perfect on try number 1 or 2. It's about iterating in the actual environment, which is incredibly harsh and complex. Ground tests just can't replicate everything.
Okay, so let's try and pull this together for you listening. Starship. Absolutely vital for SpaceX's huge Mars ambitions and their whole vision for reusable space travel.
Mm-hmm. And while the last couple of tests saw the upper stage lost, they weren't wasted flights. They yielded crucial data on specific failure points.
Right, and based directly on that learning, this 9th flight test today is it's packed with some pretty significant changes and new goals.
Yeah, from that major step of flying a reused super heavy booster with reused engines.
To those really specific engineering tests, like trying the engine out landing burn, deploying those satellite simulators for the first time.
And even deliberately stressing the heat shield by removing tiles. It all points back to that core philosophy.
This rapid iteration, learn by flying approach. It really highlights just how mind-bogglingly complex it is to build something for interplanetary travel and full reusability.
It's definitely not a straight line. It's messy, it's iterative, and you learn the most when you push the hardware in the real environment. You just have to fly.
So maybe the final thought to leave you with, considering that goal is full, rapid reusability, and they're deliberately doing things like reusing hardware right away, testing engine failures during landing, even removing heat protection. What does this whole approach, this tolerance for spectacular learning experiences. Tell us about the future of space exploration. What kind of risks might be seen as necessary to make those really huge leaps off-world? Something to ponder as we watch this next flight.